assigning priority with double and triple bonds can get really confusing. And if you just look at this molecule, you could see why. If I were to try to name this, or try to find out whether this is R or S, I wouldn't know where to begin. So what I do is, of course, the first thing we do is identify a chiral center, or see if the molecule has a chiral center. And if you go through, I'm not going to go through each one of these, but you would see that the only atom in here that has 4 things attached to it, and each of those 4 things is different, is this central one, which I've conveniently drawn out in a 3-dimensional representation. Now, what we need to do is assign priority, obviously. Now, the way that we assign priority with double and triple bonds is a little bit different. But the first thing that I want to do is see where a point of difference is. And when looking for that, I'm going to say, okay, here's my central carbon. I'm going to move to the thing that's directly attached to it. In this case, it's a carbon. In this case, it's a carbon. Over here, a carbon and a carbon. So there's no points of difference. So now we need to go to the next molecule, or the next atom that's attached. And I'm going to draw this out, because with all these double and triple bonds, it gets really, really confusing. So I'm going to draw the central carbon like this, with the things attached. And now, as we move out, we see, in this case, the first thing that's a carbon, and in every case, it's a carbon directly attached. And now, let's look at this one down here. So, attached to this carbon, we have a hydrogen. I'm going to draw that out. And now we have a double bond. Well, the way that I'm going to take care of this is I'm going to draw each one of these as counting twice. So, in this case, we had a double bond, but I've drawn this double bond out like this. And what was attached to the other side? Well, that was a C with 2 H's on it. And again, a C with 2 H's. So we're just going to pretend that this means double that. Do that 2 times. Likewise, over here, I'm going to do the same thing. So I have my C with an H attached. That's given. And now we have 2 things attached, because we're going to pretend that that double bond counts twice. And then whatever's attached to it, I'm just going to redraw. So we have the CH and a CH3. Same thing over here. That was a CH and a CH3. So you could guess what we're going to do up here. We had our carbon, and now that there were 3 bonds, I'm going to draw all 3 of them out. And each one of those, in this case, is going to get a CH3, CH3, and CH3. Now down here, there's a triple bond, so I'm going to draw 3 things coming off of it. 2, 3. I'm kind of running out of room, so I'm drawing it weird. But in each case, what is it? It's just a CH. So we have CH, CH, and CH. And I should have drawn this with the C directly attached, and then H3 like that. So now we can find our points of difference. Okay, as we move out from the central carbon, we see, okay, carbon, 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 carbon. Everybody's tied. At this point, there's no difference, because it's all attached to 1 carbon. Right? So, no difference there, so let's move out to the next thing that we see. And in this case, we're just going to start with this one. And I like to keep track of it on the paper right next to all of this. Here we have a C, a C, a C. Okay, so that's C, C, C. Over here, what's attached to this one? Directly, we have a C, and an H. Okay, same thing here. We have a C, and an H. And over here, we have a C, a C, a C. Well, which is heavier out of those guys? Well, obviously, 2 carbons and a hydrogen, it's got to be lighter than 3 carbons altogether. So we know that these 2 lose out to these 2. These 2 are going to be heavier. So I want to find out which is the lighter of these 2. And so I can move out from here and just start counting and say, okay, well, we have a C, and an H, and, well, which one of these? So we have an H. Those guys are tied, an H in both of these cases. And now we have the C's. They're tied. So what's attached to these C's? Well, here we have an H and an H, and an H and an H. But over here, we have an H and a CH3, and an H and a CH3. So obviously, these guys are heavier than these guys right here. So out of all of these, this is the lightest. It gets priority number 1 because it's the lightest, or the lowest priority. And this guy would get the second priority right here because it's the second heaviest. And now we need to say, okay, which is heavier between these guys? And right away I could see, well, okay, we're tied here with a C, 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 and a C, a C, a C. But what's attached to each one of these? Well, that's just a hydrogen, and a hydrogen. Whereas with here, we have a methyl group attached to each one. So this one's got to be heavier than this one. So since this is the heaviest, it's going to have the highest number, because it's the heaviest. And here, this has the second highest number. So now I've assigned priority. And I could say, okay, right down here, now I'm going to clean this up and write it over here. So our lightest one was this one. Our second lightest was this one. Our third was this one. And our fourth was that one. So that's how you would assign priority. Now naming this beast is is far beyond where I want to go with this. We're going to do different examples, but here you could see how you would go through and systematically find out which of these guys is heavier. And the more you do this, the more you'd be able to identify. You could, after you've done this a few times, drawing it out like this, you'll get to the point where you could say, wait, hold up. I have a tie right here with all these carbons. Then we have a triple bond up here and here, and only double bonds right here. Okay, well, most likely these are going to be heavier, and these are going to be lighter. But you need to be careful because, let's say, instead of a CH3 here, we actually had, let's say, an SH. Now, in that case, you're going to get some crazy things going on because a sulfur is much heavier than, it's in a completely different period than all the other things. So that's going to mess things up a little bit. But as you work through these, and the more of them you do, the more you'll be able to identify, little tricks and, when you could simplify and when you can't. So of course, with everything that you do in chemistry, the more you practice, the better you get at it. So this is how you do double and triple bonds when you have some kind of monster like this. It's best to just draw it all out and then go through, look for points of difference, and then just count up which one is heavier.